All right, the directions for these next few say, solve for the indicated values according to the type of quadrilateral given, round to the nearest tenth if necessary. So this very first one, it tells you from the start that this is a rectangle. So what does it mean that it's a rectangle? We learned about two properties. Number one, all of the angles were right angles. Number two, the diagonals were congruent, as well as those four individual diagonal pieces were congruent. So I'm going to mark that every single time. Okay? And so we want to know, what is A to C? Well, if A to E is 15, A to C is going to be this full amount. So if A to E is 15, I can copy that 15 for all of these other little pieces of the diagonal. That is exactly half of the diagonal. So what is the full diagonal? The full diagonal will be 15 plus 15, which is 30. Then they want to know, what is D to E? D to E is just half of a diagonal, so that's going to be 15. And then what is B to D? B to D is going to be B all the way to D, so that's stretched all the way across. B to D is going to be 15 plus 15, which is going to give me a sum of 30. So that's a full diagonal. So all of the two full diagonals are 30. Each individual piece is 15. All right, let's do that again for a rectangle. What does it mean that it's a rectangle? First, we have four right angles. Four right angles, one in each corner. And then we also know that each individual piece of that diagonal is going to be congruent. All four of those pieces are going to be congruent to each other, as well as the full diagonals will be congruent to each other in length. So we did this in class, but we talked about the different triangles that got created on a rectangle. So we have an isosceles triangle here because of those little diagonal piece sides. This side, this green side, is congruent to this green side, so that becomes an isosceles triangle. That is the vertex angle, angle 9, and the two other angles are the base angles. That angle, or that triangle, is going to be congruent to this triangle on this side. So if you were to fold this in half, those would be on top of each other, as well as this isosceles triangle at the top is going to be congruent to the isosceles triangle at the bottom. So this kind of creates like a flag-looking shape. And so if this one right here is 59, if I know that this angle is 59, who else is 59? Angle 6 would be 59, because those are base angles, those are congruent, which means that angle 1 is going to be 59 degrees, and angle 3 is going to be 59 degrees. So all four of those are 59 degrees. If those are 59 degrees, how do I find what's left of the right angle for these star angles? You would do 90, which is the full amount, in a rectangle. That full amount would be 90 minus 59. And when you do that, you're going to get 31 degrees. So this angle is 31. This star angle is 31. There's going to be 31 degrees left for each of these. This angle is 31, and then this angle is 31 degrees. Okay? All right, so how do I find what's left? What is left is we've got this piece right here, angle 10. Angle 10 is the vertex angle of that isosceles triangle at the top. So I would do 180 minus 31 minus 31. What is left? 118 degrees for these vertical angles. So how do I find what is left for angle 8? That is going to be this one right here. You could either make a linear pair with 118. 180 minus 118 gives me 62. I could also just use the fact that we have an isosceles triangle on the left and do 180 minus 59 minus 59, or minus 59 minus 59, and that is going to give me 62 as well. So both of these would be 62 degrees. So I just found every angle possible on this rectangle using the properties of rectangles. All right, so now let's go to the rhombus problems. So I'm given the fact that this shape is a rhombus. So what does it mean that it's a rhombus? Oh, goodness. What does it mean that it's a rhombus? It means I need to make this smaller, is what that means. I need to make these, all four sides are congruent to each other, as well as the diagonals are going to be perpendicular. So at point H, they cross at 90 degrees. Okay, that is going to be true of every rhombus. So if E to F, they tell me E to F is 23. What else is going to be 23? All of these pieces are going to be 23, all the way around. Then they tell me that DF, all the way across, this full diagonal is 40. If that full diagonal is 40, then each individual piece is going to be 20. So the whole thing is 40, but each individual piece is 20. And they want me to solve, one of the things that they want me to solve for is EH. So I'm going to put that in pink. That's this little piece right here. So I don't know that one, and I'm trying to solve for it. So we talked about how in a rhombus, you have 4 right triangles that get created, and they're all congruent. So how do I solve for a missing piece of a right triangle? How do I solve for x? We're going to use a theorem called the Pythagorean theorem, which says that a squared plus b squared equals c squared, where our hypotenuse in this picture is going to be 23. So I'm going to fill that in. So a squared will be x squared plus 20 squared equals 23 squared. So x is going to be equal to, when you do 23 squared minus 20 squared, you get the square root, I believe, of 129. 129, and what is the square root of 129? Let me make sure that's right. That is 23 squared minus 20 squared. You do get 129, so the square root of 129 is about 11.4. So what is EH? It's about 11.4. What would be E to G, the whole thing? Well, this would be 11.4, and then this would be about 11.4 as well. So that would be 22.8-ish. They wanted D to H. We already knew that one. That was 20. They wanted G to F. That would be 23. We already did that in purple. And then they wanted G to H, which is about 11.4 as well. Okay, so both of those are about 11.4 for our rhombus. Okay, on this problem, we're going to do the same thing. What does it mean that's a rhombus? It has 4 congruent sides, and its diagonals are perpendicular to each other. So immediately I know that angle 8 is 90 degrees. So who else is going to be, what else can I solve for? I know that the diagonals of a rhombus are going to bisect the opposite angles. So all of these green angles are going to be congruent to each other around that diagonal. And then if I draw in the other diagonal, all of these yellow angles are going to be congruent to each other. So 1, 2, 7, and 6 are all going to be congruent. So let's fill in those pieces. That would be 38 would get to be filled in for this angle 4, angle 5. How do I use what I know about triangles to figure out what those yellow angles should be? Well, if this yellow angle, obviously this is 90, this is 90. The triangle angle sum theorem says that those should add up. They should have a sum of 180. So 180 minus 90 minus 38, what is that going to give me? That is going to give me 52 degrees for each of these yellow angles that is left. So these are 4 congruent right triangles. All of those right triangles have a 90-degree angle, a 38-degree angle, and a 52-degree angle. All right, let's look at our rectangle problem again. If it says L to N, L all the way across to N, so that's a diagonal, is 4x minus 17. And then it says M to O, M all the way to O, another diagonal, is 2x plus 13. What am I able to do in order to solve for x? This whole thing is 4x minus 17. This whole thing is 2x plus 13. The diagonals of a rectangle are going to be equal to each other. So I'm going to set 4x minus 17 equal to the other expression, 2x plus 13. We're going to do some quick algebra here, and we end up getting that x is 15. So if x is 15, they want to know, well, what is L to N? You just go back and plug it in. When you plug that in, you're going to get 43. L all the way to N, all the way across is the full diagonal. So what is M to P? Half of that. All 4 of these should be the same length. So exactly half of 43 is going to be 21.5. 21.5. All right, the square, they want to know a bunch of different angles. They want to know, first of all, what is EFG? That is this full angle. That's going to be a right angle, so that's going to be 90 degrees. Then they want to know what is G to D to H. G to D to H. So that's just going to be this part. All of those are going to be right angles. So I'm going to do that in yellow. All of the corners are going to be right angles. So what is just half of that right angle in a square? It's going to be a 45-degree angle. So we talked about those right angles get bisected by those diagonals. These green diagonals come through and they bisect these right angles. So each of these small angles is going to be 45 degrees. So FEG would be 45 degrees. G to D to H would be 45 degrees, and then D to H to G, these diagonals are going to be perpendicular, so that point H, those are 90-degree angles around each of those. So what is DHG? That's this one right here that I'm coloring in pink. That is going to be 90 degrees. Okay? All right, the square just wants me to solve for x. It is a square, so this full thing is a right angle. So what is exactly this part? It's going to be half of that. So half of 90 is equal to 45 degrees. So if I get 6x equals 66, so x is going to be equal to 11. They want to know what is T to S to R, TSR, starting at T going to S going to R. Exactly half of 90, which is 45. And then they want to know for the last one, what is angle P to T to S? Remember that the diagonals of a square are going to be perpendicular to each other, just like in a rhombus. So that is going to be 90 degrees. So your assignment is on the back. This is one of those things that takes some practice. So your assignment is on the back. I gave you a chart, and then we gave you all some practice problems as well. So we will check that in class tomorrow.